We're asked to graph a couple of these exponentials and logarithmic functions. Just to get an idea of what an exponential function is, let's say you have y equals 2 to the x, or for that matter, y equals 3 to the x. They all behave similarly to y equals e to the x. Actually, e to the x should be between these two, because e is technically 2.718 to the x. So it's just a number raised to a variable. So 2 to the x is going to go through 0, 1, and grow rapidly. There's a couple of other nice points. If I go right 1, it will also go through 2. So it'll go through 1, 2, and 0, 1. And you can do a little simulation. Just plug in the 0, and 2 to the 0 power is 1. 2 to the first, plug in the 1, 2 to the first is 2. And so on and so forth. If you threw in the x value 2, it would be 2 to the second, which would be 4. And it would grow at that rate. 3 to the x, same concept. If I throw in a 0, it goes through 0, 1. But it's not the same graph, because when I go to 1, that value is going to be 3. So it's growing a little quicker. Instead of being at the value of 2 when x equals 1, it's a little higher. It's at 3. So it goes through 1, 3, and 0, 1. E to the x is the same graph, but there's really no other nice points for it to go through. So it goes through 0, 1, grows, and then you have to go over to 2.78. When you go over 1, it's at 2.718. So the value would be 1, comma, e it would go through, and which isn't really that comfortable of a number to deal with. Notice how these all grow. These all grow. Now, instead of it being a whole number in there, if I had a fraction, so if I had 2 1/2, y equals 1/2 to the x, that's the same as y equals e to the x, as y equals 2 to the x, but instead of growing, because it's a half, it decays. And let's take a look at that. So 1/2 to the first is 1/2. 1/2 to the 0 is 1. So it goes through 0, 1, and 1, comma, 1/2. So it shrinks as it goes further to the right. And then the next one would be 1/8, 1/16. If I go to the left, they get bigger. At -1, because when I put a -1, it flips this. That's going to be at 2. Y equals 1/3 to the x. Again, instead of growing, it's going to decay. It gets 1/3 of its original size. It also goes through 0, 1. Now, how would I get e to the x to decay? So in order to get e to the x, I wouldn't write 1 over e. They write it like this, e to the negative x. So e to the negative x looks like e, but instead of growing, it decays. And all these graphs could be used as trick questions. Instead of writing y equals 1/2 x, they can write 2 to the negative x. So 2 to the negative x acts the same as 1/2 x. It acts the same. That's a decay model. Y equals 3 to the negative x can be rewritten as 1/3, x to 1/3 to the x. So that would be a decay model. Now I graph this y equals 3 to the x plus 1. First, if I were to graph y equals 3 to the x, if I were to just graph 3 to the x, that would go through 0, 1, 1, 3, it would creep along, and then grow rapidly. And at 2, it would be 9 for this one. But notice, I have this plus 1. And this is going to be the opposite. If it's grouped up with the exponent, it's going to be a horizontal shift to the left of 1. So all these points, the origin, I'm going to move left 1. This point, I'm going to move left 1. And this point, I'm going to move left 1. That would give me this strange new axis that I'd reorient my graph with. And it would just grow as the original did, but all those points would be shifted to the left 1. Y equals 2 to the negative x minus 4. Well, let's look at just 2 to the x. 2 to the x would go through 1, 0. Then at 1, it would go through 1, 2. It would grow. It looks sort of like that. Actually, at 2, it would go through 1, 2, 3, 4. It actually stretch up a little bit quicker. But now notice, it's 2 to the negative x. Because it's raised to the negative x, instead of it being a growth, it's now going to be a decay. So it's going to decay along that path and go closer and closer to the x-axis. Now, after I have that graph, that idea plotted, I now need to move everything down 4 units. When it's up with the exponent, it's the opposite. When it's alongside of it, it's the same. So this is going to be shifted down 4 units on the y-axis. So my origin would go down 1, my origin would go down 1, 2, 3, 4. My go-through point would go down 1, 2, 3, 4. My axis would be at negative 1, 2, 3, 4. And it would decay. It would go through this point and it would have a new horizontal asymptote at y equals negative 4.
this horizontal asymptote was the x-axis for y equals 0. And they can ask us all about this. The domain would be all reals. The domain for this one would be all reals. The range, however, the range would start at 0 and then go upward to positive infinity. The range for this one would be where the horizontal asymptote is, which starts at -4 and goes up to positive infinity. So for this one we have e to the x, but written kind of differently. 3 minus e to the x plus 2. This is going to be a horizontal shift to the left 2. This is going to be flip over the x-axis. And then this is going to be a vertical shift plus 3. Actually, we usually put that plus 3 in the back end instead of up front there. I know the problem writes it like that, but it would be just more convenient for the student to look at the problem with the negative e to the x plus 2 plus 3. E to the x, as we recall, goes through 0, 1, and grows exponentially. And that's what the parent function looks like, of just e to the x. Now we're going to put a negative in front of that, and it's going to flip over the x-axis. So it's going to be a mirror image. Now I'm going to take that and shift it left 2, up 3. So I'm going to take this as the origin. I'm going to move that origin left 2, up 3. And that's going to give me this new imaginary x and y axis that I can just redraw this original, transfer it over there. This point, notice, goes through 0, -1, but I'm just going to move it left 2, up 3. And my graph is going to come along this horizontal asymptote, and then decay. It has a horizontal asymptote at y equals 3, and we can see that from the back end. It has a domain of all reals. And its range starts at negative infinity, and the highest it goes is 3. But it never really actually touches 3.
Now we're going to talk about logarithmic graphs. They both look kind of the same. Instead of going through 0, 1, like e and exponential graphs do, these go through 1, 0. And instead of having a horizontal asymptote as the x-axis, these have a vertical asymptote, which is the y-axis. And then they both grow slowly. They both go through 1, 0. This, however, is a base 10, and this is a base e. So all that means is for the first graph, because it's a base 10, I go right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up 1. So it would also go through 10, 1, would be its other nice coordinate. If that were a 3, log base 3 of x, it would go through 1, 2, 3, 1, would be its nice point. For ln of x, it goes through 1, 0, and then it goes through e1. It would go through e1. Not that we can calculate that accurately.
Going to graph this logarithm has a base 3, it's a log, and it has a vertical shift of 2. I'm going to do this after the fact. So the actual graph of log base 3 of x without the vertical phase shift would go through 1, 0. And then notice I have this 3, I would go right 1, 2, 3, up 1. And it would creep along the y-axis as a vertical asymptote, and it would go through these 3 points, those 2 points. And that's what it would look like. Now I'm going to move this whole graph up 2 units. So the origin goes up 2, which isn't really helpful. That would give me sort of a new x-axis. This unit goes up 2, which gives me a go-through now of 1, 2. And this point would go vertically up 2. And all because of that vertical shift. It's going to still creep along the y-axis as its vertical asymptote, and then go through that point, and pan out to the right. Its domain is restricted. The domain starts at 0, not included, and goes to infinity. For this, the range is everything, negative infinity to infinity. And we would write the vertical asymptote is x equals 0. What we have is a log base 3 of x minus 1. That's going to be a horizontal shift of right 1. And that's going to be a reflection over the x-axis. But I want to graph the original log base 3 of x. To graph that, the normal log graph goes through 1, 0. And then because it is 3, it goes through 1, 2, 3, 1. Would have a vertical asymptote of x equals 0. And then go through those 2 points. Now I'm going to reflect this over the x-axis. So what that would do is this point would remain the same, but this point would be reflected over. And instead of creeping upward, it's going to creep downward along the y-axis. Go through 1, 0, and 3, -1. And be a reflection of that original. So I have the reflection done. Now I need to shift this whole thing to the right 1 unit. It's the opposite when it's grouped with the x. So I'm going to move every point right 1. Even the vertical asymptote is going to go right 1. The go-through point of 1, 0 is going to go right 1. And the other coordinate is going to go right 1. So my new graph would still creep vertically, but this time along the vertical asymptote of x equals 1. And now it would go through 2, 0, and it would go through 3, 4, -1. The domain is restricted. The domain starts at the vertical asymptote of 1 and goes to infinity. Notice, because it's an asymptote, it really never touches the value of 1. That's why we put a parenthesis on it. The range is going to be all reals. It goes from negative infinity as the lowest y value to positive infinity as the highest y value. And my vertical asymptote is x equals 1 in this particular case. The last one is an ln graph, reflected over the x-axis, shifted to the left 4, opposite, and this should actually be rewritten in the back to show the vertical shift of +3. So I'm going to move that +3 to the back so it's easier for the student to interpret. The original ln graph, if I were to just graph ln of x, would go through 1, 0, creep along the y-axis, and then go out here at like 2.718, which is e and go through some non-exact coordinate. Now I have to reflect this over the x-axis. So it's going to go through 1, 0, but this time it's going to be reflected and go through about 2.18, negative 1, 2.718, negative 1. And now I'm going to shift this whole thing left 4, up 3. Opposite, same. So my original axis is going to go left 1, 2, 3, 4, up 1, 2, 3. And I'm going to put this fake y-axis and x-axis. And I'm just going to transfer each of these points. Left 4, 1, 2, 3, 4, up 1, 2, 3. I'm going to transfer this weird point. Left 1, 2, 3, 4, up 1, 2, 3-ish. Right? 1, 2, 3, 4. It's like sort of half. 1, 2, 3. And the graph is going to creep along this new vertical asymptote. Go through that coordinate. And then along this path. Let me get this down specifically. 1, 2, 3, 4. This is x equals negative 4. That's going to play a major role when I start to do my descriptive. The domain is negative 4 to infinity. The range is negative infinity to infinity. It's all reals. And the vertical asymptote is x equals negative of 16 over log of 2. And the calculator should be able to generate that answer. We just have to be careful typing it in. This would be rewritten as log of 1 divided by log of 5. Continuing. Really tricky to type in. Log of 1 divided by 9 over log 3. And again, all we have to do is know that move and let the calculator take control. So I'm going to type this in like I would on a TI 30x2s. In order to get that fraction, I'd have to wrap the log. And then the 16. I have to put a double parentheses, and then the division bar. And then wrap the bottom log also. Double set of parentheses. And the answer is 4. I'm going to try that with this one. Parentheses, log, 1, close parentheses again, divide, parentheses log, 5, close parentheses, and that is 0. Log base 3 of 1, 9. This is going to be a little tricky. So parentheses, log, inside the parentheses I'm going to put 1 divided by 9, close parentheses, divided by parentheses, log 3. And that is negative 2. This last one, we can't use the calculator on because it has the variable x in it. But however, ln cancels out e. So this simplified is just going to equal x plus 2. I'm asked to expand this. So I notice that there's 1, 2, 3 items in the problem. So it's going to be log, base 3, log, base 3, log, base 3. I need 3 logs to expand. 8xy. 8xy. Now I have to deal with this exponent. This one is fine, but this one has an exponent. So instead of writing that exponent up here, what the log does is it brings it out front. So it's going to be 2 log base 3 of x. You see that 3? Instead of writing that 3 up here, bring it out front. 3 log base 3 of y. Now, because it's just multiplying, whenever it's separated by multiplication, you have to put an addition sign. Whenever it's separated by multiplication, you have to put an addition sign. And that's it. That's the expansion. Log base 3 of 8 plus 2 log base 3 of x plus 3 log base 3 of y. This one, notice I have a division bar. That means there's going to be subtraction involved. I also have a radical. That means a fraction is going to be involved. The fraction doesn't involve a fraction. The fraction involves a minus. The radical involves a fraction. Kind of strange. I have 1, 2, 3, 4 items. So I have to write the word log 4 times. Log, 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 log. No base. So technically it's base 10, but I'm not going to put anything. 2x3y. 2x3y. No exponent. I have a radical. What the radical over the entire thing means is that the 3 gets a 1/2 put out in front. The radical turns into a fraction. The y is underneath the radical as well, so a 1/2 goes in front of that. Now notice I have 2 items on top. If it's on top, it gets a plus sign in front of it. Now I don't need to put the plus sign in front of that, but because this is separated by multiplication, that gets us a plus sign. Now this is separated by division. If it's on the bottom, it automatically means it gets a minus sign. The y is on the bottom. I know it's separated by a plus sign, but it's minus plus, so that's going to be a negative. And your final answer is this long expansion. Log of 2 plus, because it's multiplied, log of x, minus because it's divided. 1/2 turns into square root turns into 1/2. Log of 3, minus because it's on the bottom, 1/2 because it's underneath the radical of log y. ln. Now, if it's separated by a plus sign, you can't do anything. What logarithms and ln does is it breaks it down by one symbol, and it will break down the division to minus, but it can't break plus down. So I'm going to expand it. There's only 2 items. ln, my top item is x plus 7. My bottom item is x squared minus 5. Now this is tricky. That square is only on one item. If it was the entire quantity squared, I could bring it out front. But I can't with this. And now notice the x plus 7 is on the top, so that's addition. And the x squared minus 5 is on the bottom, so that gets subtracted. And that is my expansion. That's all there is to it.